Pythagorean's theorem is a formula used to calculate one of the sides of a right triangle. Remember, a right triangle is a triangle that has one corner that is perfectly square or 90 degrees. If you look at the three different sides of that triangle, you can identify it using a certain letter in this formula. The hardest part is determining which side is A, which side is B, and which side is C. To do this, you need to understand that the main side in it that you have to identify first is called the hypotenuse. The hypotenuse is the side that is directly across from the right angle. So if you start here at this perfect corner or right angle and you go perfectly straight across from it, this will be the hypotenuse, and it will always be the longest side in your right triangle. The other two sides are called legs. Now, in order to identify which one is A, B, and C, you will call the hypotenuse will be C, and the other two legs will be A and B. Now, which one you make A and which one you make B doesn't really matter if you mix them around, as long as you have C labeled correctly. So what we'll do is we'll use this formula in order to figure out any one of these that are missing, as long as we have two of them. So let's take a typical right triangle. Here we have two measurements given, and the third one is missing. So we know, because this is a perfect square corner, or a right angle, we know that going straight across, this is your hypotenuse, which we usually call C squared. And we don't know that, so we got to leave this right now. But if we look at the other two sides, we can call this side A and this side B. And if we write that and bring them down, we will end up with 7 centimeters for A, so I'll put that 7 in for A, and then I'll take this 4 and put it there for B. So now our formula is going to look something like this. C squared equals 7, and I'm going to leave out these centimeters just to make it easier to see. So that's 7 squared plus 4 squared. So all I did was plug in my numbers. Now if I go down a little bit and keep solving, well, I've got C squared 7 times 7, because remember, anything squared just means multiply the same number twice. So 7 times 7 is 49, and then when I multiply 4 squared, so 4 times 4 is 16. Now when I add them together, 49 plus 16 will give me 60, excuse me. If I add these together, it will give me 65. Now, I now know what C squared is going to be. Problem is, I don't want C squared, I want just C. So to get rid of this squared, okay, the opposite of squaring something will be finding the root of something. So if I take the root of C squared, because I did it to one side of the equation, I have to do the exact same thing to the other side. So I have to go root of 65. Of course, this will end up canceling out the squared, so that will be gone, and I'll be left with C. Now to find the root of 65, you're going to need to use your calculator. So if I go to a calculator that I have loaded up, I'm going to put 65, and then I'm going to use my root symbol, and it looks different on different calculators, but usually you'll see a root sign. So I'll click that. So I want the square root of 65, and my answer is going to be 8 8.06. I'm going to round it off to 8.1 because it doesn't work out to be perfect. So I'm going to say in this one, the answer is 8.1. So that's how you'd find it when you're not given the hypotenuse and you are given the other one. Here's another example. This time we're given the hypotenuse, or C, but we're not given the other one of the legs. Could be B or could be A, but look how they labeled it. They tried to fool you up by calling it H. Now I can call that any letter I want, and it doesn't matter. I just got to remember that this is one of the legs, and this is one of the legs, and this is the hypotenuse, or C. So if I take 14 and I write it there in my formula, don't forget the squared, and then I write down, I'm going to say this is A up here, so I'm going to write down 9 squared, and then I'm going to add that to this one here, and I can call it B squared or I can call it H squared, it doesn't really matter. I'm going to call it B squared, I don't know it anyway. So going on down, if I work out 14 squared, I'll need to use the calculator again and do 14 times 14, and the answer is 196. So going back again, I'll fill in 196. I know 9 squared. 9 times 9 is 81. And then I'm left with B squared that I don't know. So now, I want B all by itself on this side. So how do I get rid of 81 that's a positive on this side? How do I get rid of that 81? Well, the way to do it, if I want to get rid of 81 on this side and it's a positive 81, I will take away 81 from this side, but I must do the same thing to the other side. So this is gone, and I'm left with B squared. 196, take away 81, so I've already got 196 there. Now I'm going to subtract 81, and my answer there is 115. So I'm left with 115 on this side, and I'm left with B squared on this side. Now remember how to get rid of a B squared or anything squared on this side? You take the square root of it. And if I did that on this side, I must do the same thing on the other side. Now I'm left with just B, and I need to find out what the root of 115 is. So I've got 115 already on my calculator, so I'm going to do the square root of it, and my answer is 10.7. I'm only going to go to one place after the decimal, so 10.7 will be the answer to this question for B. Now if I go back up, remember I told you that the hypotenuse had to be the longest side? Well, this one's 10.7, and don't forget to put in your centimeters, of course. If I go back up here, this one will be 10.7. So both of them are shorter than the hypotenuse, so we know that it could be a possible answer.